G'day and welcome to the first of many videos that will be used to help you learn and understand the HSC physics course. First off, let's go over some learning intentions for what we'll be covering in this video. My aim is to have a look at the Year 11 physics course in general, get some broad strokes ideas of what you'll be covering in this part of the course. We'll be setting some key expectations, so you might get a bit of an idea of what you'll get out of the course and the kind of work that you'll need to put in to be successful. We'll have a look at the syllabus and what some things that we can do to use the syllabus effectively. And we'll also be talking about the flipped classroom itself and the purpose of it. Let's get stuck in. So first off, for Year 11 physics, we'll be looking at 4 different modules. We'll be starting with Module 1, which is about kinematics, followed by Module 2, which is called dynamics. These both focus on an area of physics known as mechanics, which is all about movement. Module 3 is waves and thermodynamics. Module 4 is electricity and magnetism. And these 2 modules are a little bit more focused on different types of energy. Now, these modules will form the foundation of your understanding of key physics concepts that will be extremely helpful to you when we move into the HSC component of the course. My aim is to deliver these modules to you in the order that they come in the syllabus. So when we look at Module 1, kinematics, we're looking at the measurement and analysis of movement. Dynamics is all about explaining why things move, so not just being able to measure and analyze moving objects, but actually figuring out what causes them to do so. The waves and thermodynamics topic is all about how energy moves, then being able to measure and analyze the movement of that energy as well. Electricity and magnetism looks at field energy specifically and how that can influence the motion of an object. We also do a little bit of work in electrical circuits as well. So when we're looking at the physics course, let's focus on what we will get out of it. What should you be expecting to learn? First and foremost, the laws and concepts of physics that underpin our understanding of the physical world is a really, really big part of this course. Obviously, you're going to learn a thing or two about that kind of stuff. Now, the most obvious connection here is to university degrees in the STEM field. The concepts that we look at do just give us a general grasp of the world around us as well. We'll be looking at learning some key problem-solving skills, again, applicable not just to the STEM field, but can be applicable in other areas as well. Big focus on being able to measure and measure precisely and accurately. We'll also be trying to improve our skills in being able to design effective experiments, as well as communicate scientific understanding using both written form, so developing our literacy skills, but also using numeracy skills to show scientific understanding through calculations, numerical representations, and graphical representations as well. Once we've got a lot of these fundamental skills, especially as we get into the HSC component of the course in Year 12, we're going to be looking at applying our knowledge to a variety of new contexts. This is going to be a really important skill that will hopefully be something that we can all work towards, because that's going to actually show a lot of our success at the end of this physics course. So when you're doing the physics course, there are some challenges that a lot of students encounter. I just wanted to go over a few of them just so you may be aware of where you might come unstuck, and we'll talk a little bit about how to alleviate some of those challenges in this video and in the future as well. First off, if you start Year 12 with a poor foundation, meaning that you kind of cruise through Year 11, you're probably going to find the course and the HSE and the prep for the exams to be a lot more difficult. Year 11 is a foundational part of the course. There are lots of things that you learn that you then need to be able to apply quite confidently in Year 12. So if you're not starting head down from the beginning, willing to take up as much as you can, you are going to find the rest of the course quite challenging. As well, a lot of students will struggle with either combining different concepts and or completing multi-step calculations. This may be something that you have not done much of in Year 7 to 10, especially in science, but these skills are something that we will definitely be building on and working towards throughout the 2 years. Another challenge that students have is that when they rote learn, that they find it difficult to combine these concepts and complete multi-step calculations, essentially attempt a lot of the complex questions that you find in the HSC, because they just learn how to solve particular problems in one way, and that doesn't prepare you to be able to apply all of the concepts and laws that we're going to be learning about in physics to completely new scenarios. Another place where students may struggle is through communicating their understanding clearly. This is something that I'm going to be working with you all on, both in the written form and numerical forms, being able to actually show that you understand and apply a lot of the knowledge that we'll be learning about, and that will prepare you quite well for the HSC. Finally, understanding complex or abstract concepts can be difficult as well. There are a handful of concepts in this course which are a little bit of a brain bender, but again, with my support and your hard work, I'm sure that we'll be able to get through a lot of those quite confidently too. So the question becomes, what do I do if I'm challenged? And to be honest, I might even think about changing this title to what do I do when I am challenged? I can guarantee that you will probably experience one or more of these points during different parts of the course. So when you do encounter those challenges, what I want you to do is reflect on the following. First, that you are not alone. This is a challenging course. So not only are your classmates going to be going through this, but people all over the state doing physics may find the same challenges that you are. Also acknowledge that not everything needs to be fixed immediately. If there are things that you are struggling with, some of that improvement that you are looking to see may come with time and support. In saying that though, we need to be working through challenges consistently. So if we just put those challenges to the side, the things that you're struggling with, and not really addressing them, and you end up leaving them too late, it may mean that you are able to reach your full potential. So if you are finding those challenges, working with me, using my support is going to be really important. And finally, low marks does not mean that you are failing or that you will perform poorly in the HSC. Because again, this course is quite challenging compared to other HSC courses, it may be more difficult to attain really high marks, especially in exam conditions. And these things actually are taken into account when your HSC mark and your ATARs are determined. So low marks does not mean the end of the world. It just means that there's more that we can be doing to try and find some more improvement. So when you are being challenged, what I want to see is all of us taking initiative in your learning, being proactive in trying to identify some of those challenges and work with your peers and myself to be able to alleviate some of those challenges. That's going to require quite a lot of persistence and patience because, again, things may not be fixed immediately. And this is the biggest one, seek support. I'm expecting that everyone's going to find challenges, but it can be difficult to try and figure out what everybody's challenges are. The more open and communicative you are with me, the better I'm going to be able to support you and support you quickly so that we can try and resolve the challenges as they come. So for the syllabus itself, that's going to be a guide for you to sort of make sure that we're moving through the course and getting through all of the things that is required. You are going to get a copy of that to look over. What I wanted to identify is that the course is split into a few different kind of points or sections. You'll find that there are outcomes and they outline the things that you sort of need to be able to do at the end. They're really big, broad, general statements. There's working scientifically statements, which are all about skills, and there's knowledge and understanding statements, and there's one for every individual module. We already talked about these modules before. They are the core sections of the course. Every module is broken up into inquiry questions, and these questions sort of underpin some of the key ideas that we find in each of the modules. And then the inquiry questions are broken up into content statements, the things that we need to do and the activities that we need to complete in order to be able to address the inquiry questions. Now, I use a bit of a dot point notation to be able to reference sections of the syllabus or individual content statements. So what I will always do is the first number using this dot point system will represent the module. The second number will represent the inquiry question in the order that it comes up within that module. And then the last number will refer to the content point. Now, when we go through the syllabus in a lot more detail, I'll show you that in class. Last thing that I wanted to talk about before we go today is having a look at flipped learning. Currently, you are engaging in a flipped learning video. Essentially, flipped learning is work to complete in preparation for class rather than homework that's given at the end. Usually, these come in the forms of short videos or readings. In particular, my focus will be on producing videos for you to watch in preparation for class. These videos will generally be slides, and a lot of the time will include worked examples, especially when there are calculations involved. So the next question that you might be asking is, why am I getting you to watch all of these videos in preparation for class? What is the value? Well, it is a first look at the new content. And what that means is you're coming into class with a little bit of a head start. Instead of me having to get up and explain the concept of the day for the first time, hopefully you're going to come in with a little bit of an idea of what we're going to be covering and the key concepts that underpin it. What that's going to mean is our lesson time is going to be much more focused on questions and problem solving, which is a benefit to you because instead of me giving you those problems to complete at the end of the period during your own time, what it means is we have more time to be able to engage in solving those problems together, again, with the support that I can offer. This will also result in less homework because it's going to mean that you're more productive in the classroom with me anyway. That doesn't mean that this is going to remove homework. Certainly at the beginning, my focus is let's just get in the habit of doing work before class instead of afterwards. And that might take a little bit of adjustment. You'll certainly be getting homework and practice questions from me, but my hope is that overall, the amount of work that you need to do by yourself, solving problems, doing practice questions, lessons, because you are able to do a lot more work with me in the classroom. So when you're watching these videos, another question that you might be asking is, what should I be doing during that time? Expecting that things may still be confusing after watching is something that's really important. Just because I've delivered the video and you've watched it doesn't mean that you're going to come out of that video knowing everything about it. We still have that lesson time to be able to net out some misconceptions, take some questions, and again, practice applying this idea to different situations. You may want to pause, think, rewind. Because these videos are coming in a digital format, it gives you the capacity to run these videos and go through them at your own pace. That also means that it gives you the opportunity to take notes in your own time, maybe prepare some questions that you know you want to come and ask me when you walk in the door first thing. And it also gives you some time to reflect on your understanding. These are the things that you should be doing to most effectively make use of these videos before coming into class. Once we're all on that same level playing field, we're going to be able to get lots and lots and lots done every single period. The last message that I want to leave you with as you start your journey in physics is work hard and work consistent. Your consistent work and your drive to pick up these new concepts, practice them, apply them, is going to take hard, consistent work. But if you do so for the next 2 years with my support and with the support of your peers, I know that we're going to be successful by the end. And I'm really looking forward to working with you all. Now, the next video is not going to be delivered in the classroom as Flipped Classroom suggests. You're going to be doing it at home. So what you'll need to be doing before next lesson is having a watch of the next video, which you can find in the Module 1 playlist, which is calculations in physics and some revision on speed. But until then, have a good one.